In this video, we are going to do a few more integration using substitution problems. So this next problem in example number 6 looks a little bit different. All of the other problems that we've done so far, we definitely had a composite function, a function inside of another function. But we really don't have that here. So we have to take a slightly different approach. But what definitely needs to be true is we need to have some function and its derivative. And so if we were to let u be equal to the denominator 3x to the fourth minus 4x cubed, and let's take the derivative of that, du dx is equal to 12x cubed minus 12x squared. Well, notice that the numerator here has an x cubed minus an x squared. So the numerator looks a lot like this derivative. In fact, it is the same. If we factor out the 12, we have 12 times x cubed minus x squared. And so they differ by a factor of 12. And so that's okay. So solving this for dx, just like we've done before, dx is equal to du over 12 times x cubed minus x squared. So we have our dx, we have our u. We can substitute everything in just like we've done before. So we have the integral of x cubed minus x squared divided by u, and dx is du over the 12 times x cubed minus x squared. And not sure what happened to my 2 there. So I am once again very pleased that these terms with the x's completely cancel out with those terms with the x's. And so what I am left with now is a 12 in the denominator, so I have 1 over 12 times the integral of du over u. Well, that's different. So that looks like the log rule, all right? 1/12 times the integral of 1 over u du. This is going to be equal to 1/12 the natural log of u plus c, which then becomes 1/12 the natural log of the absolute value of my u, 3x to the fourth minus 4x cubed plus c. And there is my answer. So, a couple things different with that. We're using the log rule. So whenever you have a problem that is of this basic idea where you have a derivative over the function, you basically have a derivative over a function, the derivative of some function u over u, you're going to be using the log rule. So look for that kind of pattern to occur every once in a while. Okay, next problem. Is another slightly different situation. So in this particular problem, I have a composite function, x minus 2. So I'm going to start like I always do with u being equal to my inside function, x minus 2, and finding the derivative. Du dx is simply 1, and therefore dx is equal to du. That's it. Dx is equal to du. So now let's substitute in. We have the antiderivative of x times u to the 5th power, and dx becomes du. And I am not a happy camper. And I think you can probably see why. I have no way to cancel out that x. The x term needs to cancel out, because whenever you do a substitution, you are eliminating all terms or anything that has an x in it, and you're putting in u's in its place. And I have not been successful in eliminating the x. So I need to come up with some way to eliminate the x. As it turns out, the solution is not so complicated. We're going to go back to how we defined u. And I'm going to solve that for x. If u is equal to x minus 2, then x is equal to u plus 2. Well, now we can substitute that in here. U plus 2 times u to the 5th du. And voila, now I'm a happy camper. We can multiply through the u to the 5th, so the integral of u to the 6th plus 2u to the 5th du, and now we're simply going to be using the power rule. So we're going to have u to the 7th over 7th plus 2u to the 6th over 6th plus c. And so that becomes 1/7. My u is x minus 2 to the 7th plus 2/6, that would reduce to 1/3, times x minus 2 to the 6th plus c. And there is my final answer. Alrighty. The next problem is very similar to this. And the next problem, we have the same situation arising, where we have to do some little tricky thing here with the x and the u. So again, my composite function is x plus 1 square root, which means that u is equal to the inside function x plus 1, du dx equals 1, or dx equals du. Well, when we substitute in, I'm going to bring the 2 out in front, we have x times u to the 1/2 du. Once again, the x does not cancel out. So I go to my definition of u and solve that for x. X is u minus 1. Well, now we can substitute that in here. So we have u minus 1 times u to the 1/2 du. Multiplying the u to the 1/2 through using the distributive property, we have u to the 3/2 minus u to the 1/2, all times du. All right, so that's 2 times u to the 5/2 times 2/5 minus u to the 3/2 times 2/3 plus c. And so that's 4/5 times, what is u? U is x plus 1 to the 5/2 minus 2/3 x plus 1 to the 3/2 plus c. So it's the same idea as the last one. In fact, the next problem is also very similar. So I'm not going to actually do this one. Oops, let's see. So this one is similar. See if you can figure out how to do that one. And let's just skip on to these last two, which are a little bit different. We haven't done any exponentials, so this one has an exponential in it. When you have an exponential function, 99.9% of the time, if not more, the u is going to be the exponent. So u is going to be equal to negative x squared plus 1. The derivative of that, du dx, is negative 2x. And so we have an x here and we have an x here. So that's good. So dx is du over negative 2x. Substituting in, we have the integral of x times e to the u times du over negative 2x. Well, the x's cancel, and I have everything in terms of u's. So we have a negative 1/2 e to the u du, and we know that the antiderivative of e to the u is e to the u. So this just becomes negative 1/2 e to the u plus c, which is negative 1/2 e to the negative x squared plus 1 plus c. And there we have it. Anything with an exponential usually tends to be fairly straightforward to do. This next one, we're going to be using this technique a lot in future sections of this course when we get into different techniques of integration. So in this particular case, we have the cosine squared of x. Well, if my inner function is the cosine of x and the outer function is the squared, I have no derivative of cosine of x. And I can't use substitution here. So I have to come up with something different. And what we're going to do is we are going to use the identity cosine squared x is equal to 1 plus the cosine of 2x over 2, which I prefer to write as 1/2 plus 1/2 cosine of 2x. And sometimes people like to put that in parentheses like that. So the integral of cosine squared x dx can be rewritten as the integral of 1/2 plus 1/2 cosine of 2x. And so we can take that, break it into two integrals. The integral of 1/2 dx plus the integral of 1/2 cosine of 2x dx. Well, the antiderivative of 1/2 is simply going to be 1/2 x. And now what about this one? So again, I like to bring the 1/2 out in front, and so we have the cosine of 2x. What does any of this have to do with substitution? Well, here's where we can do the substitution. Because now I'm going to let u be equal to 2x. And so du dx is equal to 2, or dx is equal to du over 2. And so we have our 1/2 x plus 1/2. Now the antiderivative of cosine is sine of 2x times the derivative of, and taking out, I'm sorry, doing chain rule here, and then taking out the dx and putting in the du over 2. And so we end up with 1/2 x. One thing I probably should back up here. Let me just back up a step here. I don't want to lose anybody. I think I actually kind of did it in my head and skipped this, writing out the step here. So we have 1/2 the integral of the cosine of u. Okay, we're taking out the 2x and putting in the u times du over 2. All right, I kind of skipped that part. All right, so again, we're doing u substitution. This is my u. I took it up and put in the u. Now, the antiderivative cosine is sine. So we can actually integrate this now, take the antiderivative, and so we get the sine of u. And of course, this 1/2 times this 1/2. And that becomes 1/2 x plus 1/4 the sine of u, and u, of course, is 2x plus c. That looks a little messy. My pen's not working too good. And there we have it. So this technique, I would go through this process a couple of times. Make sure that you can do this problem in your sleep. Know this trig identity, both forms of it, especially this form. Understand all of the steps that we went through to do this, because you're going to be doing this many, many, many times in future sections, as I already said. All right, so that concludes my videos on substitution. I hope you find them very helpful.